So for the 2013 multiple choice number 76, g of x is equal to the integral from 0 to x of f of t dt. And we've been given the graph of f, and we want to find g of 5, okay? So then g of 5 would be equal to the integral from 0 to 5 of f of t dt, okay? And then, so we're going to go from 0 to 5. Okay, so we have a triangle and then a semicircle, right? A half of a circle. So this area right here would be 1/2, and we're going left to right, and we're going the functions above. So the area and the integral are the same thing for the from 0 to 1. Okay, and so it'd be 1/2 times 1 times 3, and then plus, and then we have to get this area of this semicircle, right? And that'd be 1/2 pi times r. Okay, and r goes from 3 to 5, so that's a radius of 2. So 2 squared. And so this is equal to 3/2 plus 4 pi over 2. And so that comes out to be 3 plus 4 pi over 2. Or another way of looking at this, because I'm looking at the answers, okay, this would be 3/2 is 1.5 plus 2 pi. And 1.5 plus 2 pi would be answer D. Okay, all right, so let's go to the next one. So for number 77, this is a related rates problem, okay? And the volume of the sphere is decreasing, so that'd be dv dt, and it's -3. Okay, so I know dv over dt is equal to -3, and that'd be cubic centimeters per second. So centimeters cubed per second. Okay, at the instant when the radius of the sphere is decreasing, okay, so that would be a rate, and it's the rate at which the radius and it's decreasing, right? So that'd be dr dt, and we know it's decreasing, so it's going to be negative, and the rate is 0.25 centimeters per second. And then what is the radius of the sphere? Okay, so here they give you the volume, because this is the volume formula that they don't expect you to necessarily remember, okay? So to take the derivative of this, we'd have dv dt is equal to 4/3 pi times 3r squared dr dt, because the chain rule, because we're taking the derivative with respect to time, not r, right? So it wouldn't be 1 here, okay? So we could just put all the numbers in. Here my 3's cancel, dr dt, and right here's my r, right? Okay, so dv dt is -3, so that'd be -3 is equal to 4 pi, because my 3's cancel, times, and I'm going to write my dr dt first, so -0.25 times r squared. Okay, so I just switched places with those. Okay, so this is really -1/4, right? So this is going to be negative pi. So we have -3 is equal to negative pi r squared. So 3 over pi, I'm going to come up here. So r squared would have to equal 3 over pi. And so r would have to equal the square root of 3 over pi. Okay, and it'd have to be the positive one, right? Because radius is a length. Okay, so we need to put that in our calculator. Calculations like this, I'm just going to do on the calculator. I'm going to write them down. Okay, because it's when we were using the graphing calculator features that I'm going to want to pull that up. Okay, so I'm grabbing my calculator right now. Okay, so we want to take the square root, and I pushed the wrong button. 3 divided by pi, and 0.977. So r is about 0.977, and that would be centimeters, okay? And that would be E. Okay, and next, go to the next problem. You guys, number 78, I think this is a perfect example that they could ask you on the exam this year, because it's not a textbook problem, okay? All right, the number 77 is, but this one isn't, okay? So it says f and g are continuous functions, and they give you an integral from 0 to 10 f of x and what it's equal, and then integral from 0 to 10 of 1/2 of g of x dx, which is equal to 8. And then we have the integral from 3 to 10 of this difference of fx and g of x, and we know that's equal to 2. And we want to know 0 to 3 of this difference. Okay, now notice the order is the same, right? Okay, so if we want to know from 0 to 3, okay, we could go from 0 to 10 and remove the integral from 3 to 10, okay? And then that would give us 0 to 3. So what I'm trying to say here, it's easier if I write it, right? Okay, if we take the integral from 0 to 10 of f of x minus g of x, and then dx, and we remove that same integral, but from 3 to 10 of f of x minus g of x dx. So if we go from 0 to 10 and we subtract out 3 to 10, we'd be left with 0 to 3, right? That's what this is going to equal. So this is equal to the integral from 0 to 3 of f of x minus g of x dx. Okay, so we got to figure this one out, right? Okay, so we know this one, right? So this one's going to be 2. Okay, now how do we figure that one out? These are individual ones, right? So I know that this I could break up into the integral from 0 to 10 of f of x dx minus the integral from 0 to 10 of g of x dx, and then minus the integral from 3 to 10 of f of x. We don't need to break this one up because we were given that, right? Minus g of x dx. And it's going to equal that, right? Okay, so 0 to 10, from 0 to 10, I know this one is 21. So I'm going to replace that with 21 minus, and 0 to 10. Okay, so I don't have 0 to 10 of g of x. I have 0 to 10 of half of g of x, right? So another property we can do is this is a constant, so we can bring it out, right? So this is the same as 1/2 the integral from 0 to 10 of g of x dx, and that would still have to equal 8, okay? Now, how do I get 0 to 10? Well, I could just multiply both sides by 2, and I would have it, right? So the integral from 0 to 10 of g of x dx would have to equal 16, okay? So now back over here, I can replace this with 16, and then minus, and I know this one, right, this minus right here is that minus, and I know this integral from up here is 2, so minus 2, and that would be this integral from 0 to 3 of f of x minus g of x, okay? And 21 minus 16, that'd be 5, okay? And then 5 minus 2 is 3. So this is 3. So 3 is equal to the integral from 0 to 3 of f of x minus g of x dx. So the correct answer for number 78 is A. And this is, like I said, this is a perfect example of something they might ask you, similar to what they might ask you on this year's test, okay? But it wouldn't be multiple choice, right? They'd ask you to work it all out, okay? All right, so let's go on to 79. Okay, so for 79, they're giving you the graph of f prime, okay? And they're asking you which of the following graphs could be the graph of f, okay? So one thing that you want to take into consideration is where's the derivative 0? And it looks like the derivative is 0 at 0 and at 2 and at 3 and also at 4, okay? Which that translates into the function would have to have horizontal tangents at 0, 2, 3, and 4, okay? So if you look right here at 2, okay, there's not a horizontal tangent there, right? All right. So, and there's a horizontal tangent right here in between 0 and 1, and there isn't, right? So it can't be this one. So I'm going to cross that one out. I'm going to kind of eliminate these. And then at here, it wouldn't. We have a horizontal tangent at 1, right? So it can't be this one because that would mean the graph would have to cross right here at 1. So it's not this one. Okay. Looks like we have a horizontal at 0 here. Looks like we have a horizontal tangent right here at 2. Looks like we have a horizontal tangent at 3. And it looks kind of like we have a horizontal tangent at 4, okay? All right, so it might be this one, okay? We may have to do some more stuff to look at it, okay? So we have a horizontal, okay, so this one, there's a problem because there's not a horizontal tangent here. It's just going through it, right? There's not a horizontal tangent here, okay? And then there would have to also be one at 2, okay? And that kind of looks like there would be. At 3, yeah. but there would be a horizontal tangent also at 4, right? And there isn't. So the problem with this one, there isn't a horizontal tangent at 0 and 4, and there should be, okay? So it's not that one, okay? And then you go to E, okay? And so we have a horizontal tangent. We'd have it at 0. Okay, that's good. But we'd also have one right here at 1. But the graph of f prime says you wouldn't have one there, right? So it can't be this one, okay? So the only answer, we've eliminated 4 of the 5, right? So the only answer for 79 is C, okay? Guys, this question number 80 is actually from the part of the calculus that we were going to learn before the AP exam, all right? The stuff that they took out of the AP exam. So you know what, I'm going to tell you, let's skip this, okay? Because it's not, we don't need to do it, okay? Because they're not going to ask you this question on the AP exam. Now we will do this, but we're going to do it after the AP exam, okay? And I'm going to teach you all that stuff later. Because if you pass the AP exam, you're going to go to the next math class. Woohoo, okay? All right, let's go to number 81. For question 81, okay, they're giving you a cup of tea and it's at room temperature is 70 degrees Fahrenheit. Its initial temperature at T equals 0 is 200 degrees Fahrenheit. And they give you the rate, okay, at which the temperature is changing in degrees Fahrenheit per minute, okay? And they want to know what is the temperature to the nearest degree of the T after 4 minutes, okay? Now, what you have to realize is that R of T is actually a rate. So I'm going to rewrite this as dy over dt, okay? So I'm going to let dy over dt equal this rate R of T, okay? Now, what that would mean is that dy over dt would equal negative 6.89 e to the negative 0.053 t. Okay, so this is a separable differential equation, okay? So we're going to multiply both sides by dt, okay? And we would get dy is equal to negative 6.89 e to the negative 0.053 t, and then dt, okay? And then we're going to integrate both sides. So integral of dy is equal to the integral of negative 6.89 e to this negative 0.053 t dt, okay? Now, if this was e to the t, we would know how to do this, right? Okay, but it's not. It's e to the negative 0.053 t, right? So we could do a u substitution and let u equal negative 0.053 t, and then du would be negative 0.053 dt, okay? All right, so then I need to multiply and divide by this negative 0.053, okay? So I have the integral of dy is equal to, and I'm going to bring this negative 6.89 out because that's a property of integrals that you can use, okay? You can do that with constants. Okay, and I need to multiply dt by this number, but I also need to divide. So I'm just going to go ahead and bring it out and divide by it out here. So negative 0.053, and then that's the integral of e, okay? And I'm just going to go ahead and jump to u's, okay? So this is going to be e to the u, okay? Because I'm dividing by this dt, and I'm going to multiply by this negative 0.053 becomes my du, right? Because I'm actually multiplying that, or I'm just not going to write it, okay? So that's du, okay? And then I can integrate this, right? Now this number right here becomes 130. So I have the integral of dy is equal to 130, the integral of e to the u du. Okay, so this means y is equal to 130 e to the u plus a constant c. And this u gets switched back to negative 0.053. So y is equal to 130 e to the negative 0.053 plus your c, right? Now I know when t right here, okay? When I know that t is equal to 0, okay? When t equals 0, y would have to equal this 200 because that's the initial value that they gave you up here, right? T equals 0. When at time t equals 0, it's a 200 degrees Fahrenheit, okay? So that means 200 is equal to 130 e to the negative 0.053 times the t value of 0, right? So that's just going to be 0 plus c. E to the zeros is 1, Okay, e to the 0 is 1. So this is 200 is equal to 130 plus c. So 70 is equal to c. Okay, so that means y must equal 130 e to the negative 0.053t plus 70. Okay, and now I just put 4 in here, right? So y is equal to 130 e to the negative 0.053 times 4 plus 70. Okay, and if you put that in your calculator and we round to the nearest whole number, right? Okay. And I'm going to go, I'll just show you to you real quick. Okay, so it's 130 and then e raised to the negative 0.053 times 4. Come back down out of the exponent and add 70. And to the nearest whole number, it's 175. Okay, so this is 175 degrees Fahrenheit. So that would be answer A. Okay, and that's the answer for number 81. Okay, so let's go to 82. Okay, so for question 82, they're giving you the derivative f prime of x is equal to x cubed minus 4 sine of x squared plus 1. And then on the interval, negative 2.5 to 2.5, so those are our x values, okay? At which of the following values of x does f have a relative maximum, okay? So to have a relative maximum, our derivative would have to change from being positive to negative, okay? And we're going to be looking between negative 2.5 and 2.5. So I'm going to do this on the graphing calculator, all right? And I'll show you how to get your answers that way, okay? All right, so let's go to the graphing calculator. So what we want to do is we want to go in and enter our derivative into y equals, okay? And I had this in there from before, okay? And then we want to type in x cubed, so x to the third, and then minus 4 sine of x squared. And I'm going to close my parentheses and then add 1. Okay, now I want to change my window. Now, this is like the amplitude, right, of my sine function. So I'm going to go like negative 10 to 10, I think. All right. Yeah, and let's see what that looks like, okay? So window, though, we want to set our x-min to negative 2.5 because we're looking in between there, right, on that open interval, negative 2.5 to 2.5. Okay, and let's go x scale of 1. Okay, and then y-min negative 10 to 10. And then let's just go ahead and graph. Well, you know what? Let's go back because we're gonna solve it for where it's equal to 0 too, okay? So let's put in y2 is 0, okay? So this is our derivative. This would be where our derivative is 0. And so we're looking where the derivative is 0, but also it's changing from positive to negative, right? So we're going to graph it. So we're looking for where it's changing from positive to negative, okay? So right here it's changing from negative to positive, so that would be a relative minimum, okay? And then right here it's changing from positive to negative, so that would be a relative maximum right there. And then this would be another relative minimum right here because it's changing from the derivative is changing from being negative to positive at this x value, okay? So it's this one right here that we need to find, okay? So we go to our calculator and press second, trace, and 5 for intersect. And then let's just get close to that one we're trying to find, which is this one right here. And just press enter for selecting the derivative function. Enter for selecting 0, and then just press enter because you're close to it. And the answer is 0.542, okay? All right, so let's go back and let's look and see which one is that, okay? So we got 0.542 only, right? That was the only one we got, so it's E. Okay, so for 82, the answer is E. Let's go to 83. Okay, so I'm going to actually do this problem 2 different ways, okay? Now, what we know is that our function is increasing, right? From 0 to 3, okay? Because it says that f is increasing over the closed interval 0 to 3. So, okay, so if we do this, right? Let's say we have something like this, and we do a left Riemann, right? Our rectangle is going to come up on the left side, right? And so if we do a left Riemann for this function, okay, then we know whatever we get, the actual integral has to be a little bit larger than that, okay? If we do a right Riemann, okay, then our function would look like, our rectangles would look like this, and we're going to get a little bit of extra area each time. And that's happening because the function is increasing, okay? So this is a right Riemann, and this is a left Riemann, okay? So I'm gonna do both of these and take a look, and we're gonna see what happens, okay? If you do both of them, then your answer has to be in between those, okay? That would be true too, okay? All right, so here we go. So I know that the integral from 0 to 3 of f of x dx, okay, can be approximated. Now we're gonna do intervals of 0.5. Now these are consistently going across, they're equal intervals, right? So it's gonna be 0.5 times the left side, which would be 0, and then plus 0.5 times 4, and then plus 0.5 times 10, and then plus 0.5 times 18, and then plus 0.5 times 28, plus 0.5 times 40. And that would be the last one, because we're doing in between 2.5 and 5 for this last one, right? And the left side would be 40, okay? So this would be 0. This would be 2, right? So we could approximate this with 0 plus 2 plus 5 plus 9 plus 14 plus 20, okay? So this would be 7 and 14, which would make 21, with the 9 makes 30, plus the 20 makes 50. So this is about 50, right? Now, what was this? This was a left Riemann, right? So if that's the left Riemann, okay, it can't be this answer right here, because our actual value has to be a little bit bigger. So I would say it's going to be 62, okay? All right. Now, if we do a right Riemann, okay, that'd be the integral from 0 to 3 f of x dx, okay? And you need to write this for the AP exam, because it's not going to be multiple choice. Now, if this was an actual AP exam with multiple choice, you wouldn't need to show this. You could just work it out, okay? But you got to show correct notation with this, okay? So this is going to be equal to 0.5 times, and we're going to do the right side now, right? So it'd be 4 plus 0.5 times 10 plus 0.5 times 18 plus 0.5 times 28, and then plus 0.5 times 40, and then plus 0.5 times 54. Okay, so this would be 2 plus 5 plus 9 plus 14 plus 20, and then plus 27, okay? So 2 and 5 makes 7. The 7 and the 14 make 21, okay? And 21 and 9 makes 30. So this be, and with the 20 makes 50, and 50 and 27 makes 77, right? Okay, so now what is this one? This was an overestimate, right? And this was an underestimate. Okay, so therefore it has to be somewhere in between, right? And that would be 62, like I said earlier, right? It's going to be a little bit bigger than 50. So if you had chosen, like on this problem, if you had chosen just to do the left Riemann, right, you had to realize, okay, they gave you 50 because that is the exact, right? But that's an approximation for this, okay? Not what could be the value of it. It would have, the value would actually have to be a little bit bigger. That's why we chose 62, okay? And if you use just the right Riemann sum, okay, the 77, you should know that that's an overestimate, and it's right there, and you shouldn't select that one, right? It's got to be a little bit lower than that, right? So 62, okay? Or if you do both of them, it's somewhere, it's got to be somewhere in between, and the only one that's in between 50 and 77 is 62, okay? So the correct answer to 83 is B, okay? All right, I kind of did that longer than you really need to, okay? All right, but I want you to understand this, okay? It was important that you understand the over and underestimate, okay? And it's because it's increasing, and then the left and the right Riemann sums, okay? All right, we'll go to the next one, 84. Okay, so for number 84, they're giving you the graph of f, and they just which of the following statements is true, okay? So f of a equals 2. Well, that's false, right? This is false because the graph tells us f of a is really 1, okay? F is continuous at x equals a. No, f isn't, right? Because you have a discontinuity. The limit and the function value don't agree, right? They're not the same thing, okay? So this is also false. That's a removable discontinuity, okay? The limit as x approaches a is equal to 1. That's false. Because as you approach, you're going to get closer and closer to this open dot, right? The limit as x approaches a of f of x is equal to 2. That's true. Okay? And the limit as x approaches a of f of x doesn't exist. Well, no, that's not true either. That's false. It does exist because we just did it right up here. It's 2, right? So the correct answer to 84 is D. Okay, 85. Okay, so for number 85, it's a particle moving on the x-axis for time t greater than or equals to 0, okay? Its position is given by x of t is equal to cosine of the square root of t, okay? And then what is the velocity of the particle? At the first instance, the particle is at the origin, okay? So what we're gonna have to do is we're gonna have to find the time that it's at the origin, okay? And then we're also going to have to find the derivative of this to get the velocity, right? And whatever time that is, we're going to put in. We're going to completely do this on the graphing calculator, okay? All right, so let's go to our graphing calculator and I'll talk us through it. Okay, so from y equals, okay, we want to type in our function, and it's the position function, right? So it's cosine of the square root of t, which we'll have to put in as the square root of x. Okay, and it says time is greater than or equal to 0, so we got to go to our window, and our x min should be 0, okay? And our x max, I'm going to go all the way out to 10, okay? So that would be 10, I think it's seconds. No, they didn't tell us time. Okay, so let's just go out to 10, okay? And then x scale, I'd go by ones, excuse me. And then y min, okay, so it's cosine, right? So it's gonna, the highest it's gonna go is 1, and the lowest it's gonna go is -1. So I'm gonna go from -2 to 2. And just y scale at 1. Okay, and then I wanna go back to y equals, and I forgot, I wanna put this in for 0, okay? Because where this position function is 0 is where the particle would be at the origin, okay? Okay, so let me go back to, and we'll look at graph, okay? So what this means is this is positive position. So this would mean it's to the right of the origin. And this is negative position. So that'd be to the left of the origin. So it had to have passed the origin right here at this time value, right? So we got to figure out that time value. That's why I put in y equals 0, because I wanted to do the intersection right here, okay? So we're going to do that. We're going to press second, calc, trace. Sorry, my neighbors have the lawnmower going, okay? We want to intersect, okay? And then I'm going to get close to where I want to find it at, right there. And I'm going to select the first curve, which is the derivative. You can see it up here, okay? And then y equals 0, press enter. And then guess, just press enter again, okay? So it's this value right here, 2.467, okay? Now we want to use this entire value when we find the derivative, okay? So we're going to go back to our home screen. So second quit, okay? And if we type x right now, that's the x value we just found, that 2.46, okay? So I'm going to store it. So I'm going to store that answer as alpha a, okay? So alpha, so store down here, and then alpha a, and press enter. Now, whenever I type a, I'll have it, okay? All right, so now we want to take the derivative of the position function at this time value, okay? So we're going to go alpha window 3 for numeric derivative, and we want to take the derivative with respect to x of our position function, which we have stored as y1, right? So alpha trace y1, and then we want to find this at what x value? We want to find it at this value right here, which we call a. Now you could do this, go up on top of it, highlight it, and then press enter, and I think it'll put it here. Or Or the whole point of storing it as A is we can just press alpha and A, okay? So if we do that, okay, you get this value, right? It's negative 0.318. And you look at it, the answer choices, and that's one of them, right? Now you would write, okay, x prime of this negative 0.318 as this number, okay? So I'm going to go back to your calculator. I'm going to do the notation on this to show you how to do the write-up on this, okay? Because you're going to have to do a write-up on this for this year, okay? All right, so let's go back to our graphing calculator. Go back to our paper, all right? Okay, so this is how you'd have to write this up, okay? So you'd have to write x of t, and we're going to figure out where that equals 0, right? We solved this equation, right? So you got to write an equation that we're going to have to solve, okay? Now, instead of x of t, you could put cosine of the square root of t equals 0, right? Okay, and then you got to give me the t value, okay? And so the t value was 2.467. Now it's more than that, but you can just write that, okay? But if you do any calculations, you need to do use the entire decimal that's in your calculator, okay? All right, so it's fine to write that, but just use in any calculation the full decimal, okay? Now, what do we want to do? We want to find x prime of 2.467. Now, why are we doing that? Because that's the velocity, right? So this is equivalent to velocity at 2.467. And what we got out for that is negative 0.318. So you'd have to write up the equation that you're solving, okay? And then you showing that you're putting that value that you solved for here into the derivative and getting your final answer, okay? Which is C, okay? And that's what you would need to show for the AP exam this year, okay? Let's go to 86. Okay, this is an excellent question, okay, for number 86. And it says, if f double prime is greater than 0, okay, now if f prime is greater than 0, that tells us our function has to be increasing, okay, and, for all x. And f double prime of x is less than 0, okay, that would mean the function's concave down, okay, but it would also mean that where the second derivative is negative, that would mean f prime has to be decreasing, okay? All right. So if you look at this, what this well, let me say this a little bit more, okay? This means our function has to be increasing at a decreasing rate, okay? So I'm going to write this. F prime of x greater than 0 means our function has to be increasing. F of x is increasing. And then f double prime of x is less than 0, okay? So f of x is increasing at a decreasing rate, okay? So if you look at this right here, okay, now this is nice about these tables. The delta x is 1, right? We're going from -1 to 0, 0 to 1, right? For each of these, okay? So I'm going to kind of ignore that, okay? Because the delta x is going to be 1 for all of these, okay? So right here, the change between 4 and 3 is -1. That means that between -1 and 0, there has to be a derivative that's -1, right? And then it goes from 3 to 1, right? That's a change of -2, right? Okay, so if you look at this, our function is decreasing, but what do we know? Our function has to be increasing, right? Because these have to be positive. That's what this is saying, right? So in between -1 and 0, there has to be a derivative that's -1, but this says our derivatives have to be positive, right? And if you look at this, the f prime is going from -1 to -2, right? That's a decrease, right? So what this is describing, okay, is that f of x is decreasing at a decreasing rate, okay? All right, so that's not the choice, right? And then if you look at these, okay, because again, my delta x is 1, right? This changes 0. This changes 0, okay? So that means there has to be a derivative between -1 and 0, okay? That is 0, right? But what does our thing say? It says it has to be increasing, right? It's not increasing, right? So it's not this one. You know what? I'm going to cross these out. So it's not that one. It's not that one, okay? Now, how about this one? 4 to 5, okay? So 4 to 5, I know it's increasing because that's a change in 1. Again, my delta x is 1, right? That's an increase of 1, positive 1, right? And then 5 to 6, that's an increase of 1. So it is increasing, right? It is increasing, but it's not increasing at a decreasing rate because it's staying the same, okay? So we would say on this one, f of x is increasing at a constant rate, okay? Okay, this next one, okay, 4 to 5. 4 to 5, that's an increase of 1. 5 to 7, that's an increase of 2, right? Okay, so f of x is increasing, but it's increasing at an increasing rate because we're going from 1 to 2. Okay, so these are increasing and our derivatives are increasing, right? Our derivatives have to be decreasing, okay? Okay, so then let's go to this next one, okay? So from 4 to 6, that's an increase of 2, and then from 6 to 7, that's an increase of 1. Okay, so is f of x increasing? Yeah, because my derivatives are positive, right? These would be some derivative in between here that would be 2, and this would have to be some derivative in here that's 1, right? And notice what's happening. The derivative is 2 here and 1 here, so it is increasing at a decreasing rate. So the correct answer is E, okay, for 86. Okay, okay, so this is f of x. Let's write these, okay? F of x is increasing at a decreasing rate. This one is f of x is increasing at an increasing rate, okay? And then this one would be f of x is increasing at a constant rate. This would be f of x is not increasing. Okay, and then this one would be f of x is decreasing at a decreasing rate. Okay, so that explains all 5 situations. Okay, all right, so let's go to 87. So for 87, let f be the function with first derivative given by this, okay, this 3 minus 2x minus x squared times sine of 2x minus 3. How many relative extrema does f have on the open interval -4 less than x less than 2? So relative extrema would be where this derivative changes from positive to negative or negative to positive, right? So we're going to look at the derivative graph between -4 and 2, okay? And we're going to see where it changes signs, okay? Now, since this is sine, and well, this is going to change, right? This amplitude right here, okay? So I'm probably going to go like from -8 to 8, and let's see what that looks like, okay? So we're going to go to our graphing calculator, and we'll finish this problem. Okay, so we want to go to y equals, and we want to put our derivative in, okay? So parenthesis, and then 3 minus 2x minus x squared. And close parenthesis, and then sine of 2x minus 3. Okay, and we could do y2 is equal to 0. We don't need to actually solve them. We just know how many there are, okay? Okay, so that's y1 is our derivative. Okay, then our window, we want to set our x min to -4 and our x max to 2. Okay, and let's just keep y min -10, y max 10. Let's just keep it there, okay? And let's press graph and see what we have. Okay, it looks from the way I did this, okay, there's 1 right here, and that's changing from negative to positive, okay, and then positive to negative, and then negative to positive, and then positive to negative, and then negative to positive, and then positive to negative. So it looks like, okay, and I'm going to do, this would be a perfect problem where let's do zoom box. Okay, so I'm going to go to zoom box to get this right, okay, and I'm going to go all the way to -4 to the left. Actually, I want to get my maximum up here. I want to be above this. You know what? I don't want to do that. Okay, I want it right there. And then I'm going to go across. And then I'm going to go down. And you'll just be able to see it a little bit better if we do this, okay? And then I'm going to press enter and graph this one. Okay, you just see this maybe just a little bit better. Okay, so 1, 2, 3, 4, 5, 6. So this happens, there's going to be 6 relative extrema on the interval -4 to 2, okay? Because there's one right here, right? And this would be a relative, because we're changing from negative to positive. This would be a relative minimum. This would be a relative maximum. This would be a relative minimum. This would be a relative maximum. This would be a relative minimum. And then this would be a relative maximum, okay? All right, so let's go back and let's answer this. So there were 6 of them, right? Okay, so let's go back and answer it. So from the graph, we saw that there was only going to be 6 of them, right? So let's just circle 6, okay? Let's go to 88. Okay, so for 88, they're giving you the graph of f, and they're asking you for different first derivatives at different x values, okay? So let's take a look. And a lot of times what happens is these are going to be either negative, positive, or 0, okay? And so you'll be able to order them because of that, okay? So f prime of -1, right? So that looks like this one would be 0, right? And then f prime of 1. F prime of 1 is negative, okay? Right? Now, how do I know it's negative? Because that slope right there it's decreasing, right? Function is decreasing. That would mean right there at x equals 1, which would mean the first derivative would be negative, okay? So this is negative and this is 0, right? Well, negative has to be smaller. So this isn't it. This would be false. Okay? And then f prime of -1. F prime of -1 is 0. F prime of 0 would be positive. Okay, so that's the right order for those, right? Because this would be 0 and this would be positive. How about f prime of 1? F prime of 1 is negative. Well, that's not true, right? Okay, so this one's false. And then f prime of 0. So f prime of 0 is positive. F prime of -1 is 0. Well, that can't happen because positive is not less than 0, right? So this one's false. F prime of 1 is negative. Okay, that would be good. F prime of -1 is 0. Yeah, that's true. Okay, and f prime of 0 is positive, right? Because there's a positive slope right here. Okay, so this one's true, right? Now let's just double check. This one's got to be false then, right? Because there's only one of them that's true. Okay, so f prime of 1 is negative. So this would be negative. F prime of 0 is positive. So that's true. Negative is smaller than a positive value. Okay, and then f prime of -1 is 0. Well, that's not true, right? So this one's false too. So the correct answer for 88 is D. Okay, let's go to 80. So problem 89 is a problem that we can skip because this is going to be on the part that I'm going to teach after the AP exam. Okay, so you won't be tested on 89. Okay, all right, let's go to 90. Okay, so the population P of a city grows according to this differential equation. Okay, K is a constant and T is measured in years. If the population of the city doubles every 12 years, what is the population? What is the value of K? Okay, so this is a separable differential equation. Okay, so what we have is dP over dt is equal to Kp, right? Okay, so we need to get our dP and P on the same side and our K and dt on the same side, okay? So this becomes 1 over P dP is equal to K dt. And then we want to integrate both sides. So integral of 1 over P dP is equal to the integral of K dt. Okay, so this is the natural log of the absolute value of P is equal to KT plus some C, some constant C. Okay, now population, it has to be positive, right? Because population is always positive, right? You have to have you can't have negative number of people, okay? You can have a negative rate at which the people are changing, but you can't have negative population. So we don't have to worry about the absolute value on this. So I'm going to change this to the natural log of P is equal to KT plus C. Now we really don't have like the initial value, right? We have that the city doubles every 12 years, okay? So instead I'm going to start to solve this for p, okay? So I'm going to exponentiate both sides. So e to the natural log of p, because that's going to give me p, is equal to e to the kt plus c. Okay, now this left side becomes p because they undo each other. This, we're adding exponents, right? So this is e to the kt times e to the c. And that's a new constant, right? So I'm going to call that a. I wouldn't want to call it k because k is already being used, okay? So we're going to let a equal e to the c. So that means the population is equal to a times e to the kt. Okay, well that doesn't really help you find k, right? We got the population formula, right? But we don't know this constant a and we don't know this constant k, and we're actually trying to find the constant k. All right, so the next thing you can do is we know after 12 years after this time, this will be double whatever p is, right? So what we can do is we can write this as 2p is equivalent to, okay, a e to the k, and this time will be 12 years later, so it's going to be t plus 12. So times t plus 12, okay? And then something else you can do, well, let's just go ahead and do this. Okay, so 2p is equal to a e to the kt plus 12k, right? And then this can be rewritten because we're adding right here. So this would be 2p is equal to a times e to the kt times e to the 12k. And you're still might be wondering, like, where are you going with this, right? Okay, watch what happens though. We know what p is, right? P is this. That's the same population right here. P is p, right? P is p. Okay, so what that means is this population number right here, this p, can be replaced with a e to the kt. So that means this is 2 times a e to the kt. I'm just replacing population with what it's equivalent to, and that's equal to a times e to the kt times e to the 12k, and then a times e to the kt, right? We can divide both sides of this equation by this, and what would we be left with? We'd be left with 2 is equal to e to the 12k. Now, why is that helpful? Because now I can solve for it, right? So what I'm going to do is to undo this e, right? I'm going to take the natural log of both sides. So the natural log of 2 is equal to the natural log of e to the 12k, which means the natural log of 2 is equal to 12k, which means k must equal the natural log of 2 over 12, which is about, if we go and put in our calculator, 0.058. That's rounding to 3 decimal places, okay? So the correct answer for number 90 is A, okay? All right, they make these problems so on the graphing calculator part of this exam, which is what we're on, okay? They would make these, they're about 3 minutes each, okay? All right, so that's about the time frame you should take. All right, so let's go to 91. Okay, so for 91, they're giving you the integral from 0 to 8 f of u du is equal to 6. And then what is the value of the integral from 1 to 3? K times f of x squared minus 1 dx, okay? Now notice something. This is an inside function, right? And the derivative of x squared minus 1 would be 2x. Here's my x, right? I just need to get a 2 here, okay? So this is an integration by substitution problem. This is a non-textbook problem that they would easily ask you on this year's AP exam, okay? Because it's not something you can look up. You have to understand it, okay? So we're going to let u equal x squared minus 1, and then du would have to be 2x, right? So this integral from 1 to 3 of x f of x squared minus 1 dx. So I'm going to write it up like you would have to for the test, okay, is equivalent to, okay, so this is going to be my u right here, right? And I need du, but du, I forgot to write dx. Okay, So I have the x and I have the dx. I need the 2, right? So I'm going to have to multiply the outside by 1/2 and the inside by 2. So this would be 1/2 times the integral from 1 to 3 of x f of x squared minus 1. I forgot to put the 2. 2x f of x squared minus 1 dx is equivalent to, okay, now we're going to switch everything to u's, okay? So we still have this 1/2. We have our integral. Now, these are no longer going to be x values because that's what they are right now. They're going to change to u values, okay? So what is 1 squared minus 1? Well, that would be 0. And what is 3 squared minus 1? Well, that would be 8. See how it matches up with this one? Okay. And then this is going to be f of u and then du. So f of u du, right? And that's what we have. This integral from 0 to 8 f of u du is 6. So that means this is equal to 1/2 times 6, or 3. And so the correct answer to 91 is B, okay? Again, you wouldn't be selecting them. You'd be showing all this work right here, okay? That's what you need to show for the AP exam, okay? You need to show your work, okay? All right, so that's why I'm going through these multiple choice with you, okay? I realize we're not doing multiple choice questions on this year's exam, but the practice of doing these is showing you situations that I think will be beneficial to prepare you for that exam, okay? Where you write it all out, okay? All right, as long as you guys are doing these, okay? All right, let's do 92. Okay, so 92 is testing you on what's called the extreme value theorem, okay? So the function f is defined for all x in the closed interval, okay? So you have values for the function. It's not undefined anywhere, okay? If f does not attain a maximum value on the closed interval a to b, which of the following must be true? Okay, on a closed interval, if the function's continuous, it must have a maximum and a minimum. Okay, on a closed interval, if a function is continuous, it has to have a maximum and it has to have a minimum. Okay, that's the EVT, the extreme value theorem. Okay, if it's continuous, right? So we have a closed interval, but we don't have a maximum. That means it has to if it was continuous, which means it isn't continuous. And the only selection for this is A, okay? All right, I would say they might ask you questions like this and you'd have to write up f is not continuous on A to B, okay? All right, that's not a textbook question either, I don't think. All right, okay, so that's 92 and I think that's the end of the exam. Yes, it is. Look, end of section, right? Okay, so we're done with this one. All right, just hang in there, guys. Just keep practicing, keep practicing. The more problems you see, I think that's why my students do well. We just go through a lot of problems so you become familiar with the format of the test, okay? And you get better and better and better at these, okay? I'm not expecting like perfection. Like if you're getting everything right on these, you're probably cheating, okay? All right, it's okay. I've made some mistakes. You don't see my mistakes, where I've had to go, crap, that's not the right answer, okay? I've thrown it away, right? And I've gone back and reshot the video for that one, okay? You guys don't know that, but that does happen to me, okay? All right, so you're seeing this perfected, okay? You're gonna miss, okay? And I'll tell you the truth, on this one, I've missed 2 on it, okay? I had to recorrect and on a couple of these, all right? So it's okay to make mistakes. I expect it, okay? Nobody's expecting perfection. Nobody, okay? Just do the best you can on these, all right? That's all, okay? Hang in there, guys. Take care. Bye.